Hello everybody, and welcome to today's Dynamics 365 Tech Talk. Today's topic is D365 and Dataverse integration overview. My name is Adamu, and I will be your moderator today. We are broadcasting this session through Teams live event. Presenting for us today from Microsoft, we have Corina Balan, Senior Solution Architect in the Fast team, and Michele Mazzucco, Senior Solution Architect in the Fast team. Michele, over to you to get us started.
Thanks, Ali. And hello everyone, and welcome to the second Tech Talk in our series dedicated to Dynamics 365 integrations. In part 1, we gave an overview of the endpoints and components that are available in Power Platform and Azure to build your integrations. The session has been recorded, and you can find the links on the Tech Talk Dynamics community page, or you can also use the QR code included in this slide. In today's session, we will be focusing on Dataverse integration patterns. Next episodes in the series will be dedicated to integration patterns for finance and operation and additional complex and mixed scenarios. During part 1, we gave an overview of the different endpoints and tools offered by Power Platform, our business applications, and Azure. Today, we focus on the endpoints and methods that are relevant for Dataverse specifically, and the Azure components that can be used to build Dataverse integrations. We will discuss inbound and outbound integration patterns, so bringing data into Dataverse from external sources and send Dataverse to external systems. We will see some examples of common integration scenarios in these areas, and at the same time make some considerations about scaling, security, and best practices. We will also share some useful resources for you to review, and of course, please feel free to post your questions in the Q&A panel. Let's get started with inbound integrations. When we think about bringing data into Dataverse, there are different approaches we can evaluate. One approach is to write code to interact directly with the Dataverse API. When doing this, we have two options: the organization service, which defines all the operations supported by the platform as messages, and is accessible from .NET code through the provided SDK. The web API, which exposes the same operations as a RESTful service and can be consumed via HTTP methods, leveraging OData to define functions and actions. Another possibility is to implement your integrations by using components in Power Platform and Azure that rely on connectors to interact with Dataverse. This allows for a low-code, no-code approach, and again, you have multiple options. For example, Power Automate, which is a SaaS component, has a wide set of pre-built connectors and can be included as a component in solutions. Logic Apps, which offers similar flows capabilities in a pass mode, allows pro development through code editing and is deployed as an Azure source. Data Factory, which is meant for complex ATL and data integrations, especially with large amount of data. Integrating external data in Power Apps or Dynamics 365 business applications doesn't mean necessarily that data must be physically imported in Dataverse. You can evaluate to embed the real-time data from external sources in your UI. For example, you can leverage virtual tables that allow you to expose external data in any model-driven app. You can implement custom controls or custom pages that would offer a specialized UI to query external data. And of course, the reporting option, especially with Power BI, that can be embedded into your application forms to aggregate the data from external sources. Deciding how to proceed between all the available approaches may depend on a lot of different factors. For example, you may have to extend an existing application which already defines some technology requirements, for example, a specific programming language. Again, your organization may have invested already in a specific architecture, for example, a middleware, which will limit the choice of components and related product licenses that you can use in your project. Let's see how you could decide between the available options when starting a new project. The first question you need to ask is, do you actually need to write code? If you just need to handle orchestration of events coming from an external system, you could evaluate if an existing connector is available and just implement Flow. We'll see that in the next slide. If you decided that implementing custom code is the right thing to do, the next question will be, can you implement your code in .NET? If the answer is yes, then you can rely on the provided SDK assemblies, distributed as NuGet packages, as they will provide different benefits. They will offer helper methods to establish Dataverse connection and perform authentication steps. They will also offer specialized classes and methods like entity, entity collection, retrieve multiple, and so on, to implement your business logic with Dataverse operations. If you are not using .NET, Dataverse will expose all the same operations with OData. In this case, you'll need to implement Dataverse calls as HTTP methods, and we suggest you use the Microsoft Authentication Library to simplify authentication steps. For more information about the organization service versus the OData Web API, the SDK assemblies, and Microsoft Authentication Library, please see the linked resources in the following slides. If you establish that you don't need to write custom code and you can rely on existing Dataverse connectors, there are still a few considerations you can do. First of all, you need to ask yourself if what you are designing is a broader data strategy to move high amount of data regularly. If that's the case, you likely want to evaluate to implement a data factory pipeline. If your requirement is to handle orchestration of events between applications, then a flow might be the right option. In this case, you need to understand the context of your implementation and think of factors like license and cost management, the ALM strategy you wish to implement, the design tools and related skills that will be required to your team, and so on. Basing on these elements, you could decide whether Power Automate or Logic Apps are a best fit. While similar in the approach, they may differ in some details. For example, Power Automate licenses might be included in your Power Platform and Dynamics 365 offering, while Logic Apps will be built in your Azure subscription. Power Automate flows can be included as solution-aware components, while Logic Apps are deployed as Azure resources in a resource group. Power Automate can be authored only through the provided designer, while Logic Apps allow authoring in Visual Studio, and so on. You could also conclude that, while you need to implement orchestration, a connector is not a suitable way, and decide to go back to a code-first approach by implementing durable functions. For a detailed comparison of the different components and a reference to existing connectors, please see the resources we are linking in the following slides. Here you have additional documentation resources for further reading on the concepts we discussed so far. Let's now see an example of a possible use case. In this scenario, we'll simulate the need to react to a message coming from an external application and process that data in Dataverse. Specifically, we'll simulate a requirement where a new contact is notified from an external application, for example, a website with a contact us section, and this data must be created as a new contact record in Dataverse. For this scenario, we decided to design our solution around Azure Service Bus. Service Bus allows the definition of queues to implement a sender-receiver scenario, or a more complex structure with topics and subscriptions to implement a publisher-subscriber scenario. In our example, Dataverse is the only receiver of the message, so we just need a simple queue. We will discuss the usage of topics further in the presentation, and you can read more on topics in the linked documentation. Our example will then use an Azure function to be triggered when a new message is added to the queue. The Azure function will process the incoming message and use the .NET SDK to connect to Dataverse and perform the required data operations. Let's have a deeper look at the required components. First of all, we'll start by creating a new Service Bus resource. This will generate a Service Bus namespace. From the Service Bus namespace, we can create a new queue. During the creation of the queue, we can set some parameters affecting its behavior. For example, the maximum number of deliveries retries before the message is sent to the dead letter queue, the time to leave, which is the timeout for receivers to process the message, and so on. The dead letter queue is the place where Service Bus holds messages that can be delivered to any receiver. For more information about retry policies and the dead letter queue behavior, please see the linked documentation. We now see our queue listed in the Service Bus namespace. We create a new function app resource. We then use Visual Studio to create a new Azure function project. This is the easiest option because the project template will help us initialize the bindings for the Service Bus queue trigger and all related required assemblies. Visual Studio will also help us handle the publishing process after we provide the connection to our Azure subscription. After publishing, we'll be able to see the new function in the function app. The function code is implemented as a C# class, which will initialize the bindings to the Service Bus trigger, provide access to the message parameter, and expose an interface for logging. In this example, we are using a Service Bus trigger to process a single message, but it's also possible to configure your function to process a batch of messages at the same time. For more information on this, please see the linked documentation. To deserialize the message, we define a simple class to match the expected format of the message body. To connect to Dataverse from our function, we leverage managed identities. Managed identities are a great approach because they will simplify the authentication steps, removing the need to handle secrets in your code. See how there are no secrets or credentials in this code. They will also be matched with a valid service principal, which can be registered in Dataverse as an application user for correct security profiling, like applying security roles and privileges. This will result in cleaner code and help avoid potential security issues that will generate from handling credentials in your code. Additional security and flexibility comes also from being able to assign specific privileges and roles to each application user. We'll see that better in the next slides. Managed identities will also allow for better scaling of your code, as by leveraging different application users for different integration channels, you can avoid exceeding the API calls limits, which will result in throttling situations. To learn more about managed identities and service protection limits, please refer to the linked documentation. To execute operations on Dataverse, we rely on calling a custom API. This has different benefits. First of all, our function will perform only one call to the Dataverse endpoints, reducing the consumption of API calls entitlements. Also, our business logic can be grouped on Dataverse side in a single plugin, exposing one simple action to the function. Please note that any exception in the code will force Service Bus to retry the delivery of the message and increment the retry counter. Only when your code completes without exceptions, the message will be consumed and removed from the queue. You should throw an exception only when catching transient errors that might have a different result on the next try. For logical errors, for example when the content of the message doesn't allow the operation to be completed successfully, a retry would probably not help. To learn more about exceptions and error handling during message processing, see the linked documentation. We now create the custom API in Dataverse, and we specify a privilege requirement so we'll be able to restrict access to the custom API with security roles. In our case, we rely on the create contact privilege, as that is the main purpose of the API. We can then assign a dedicated security role with this privilege to the application user corresponding to the Azure function. We configure properly all input and output parameters of the custom API to match the contents of the expected messages. Finally, we create a new plugin assembly to implement the business logic of the custom API. The plugin will implement all the steps to validate input parameters, check for duplicate records on existing contacts based on name or email, resolve lookup references for the company code or company name, and finally create the new contact record. Like we mentioned earlier, if all these steps were performed as separate operations directly in the Azure function, it would result in multiple API calls that count towards the entitlements and service protection limits. Also, please note how we make use of alternate keys to resolve entity reference for lookup field and avoid an additional query. The plugin is then registered to execute synchronously on the message associated with a custom API. Let's see this in action. We simulate the external application by sending a new message from a REST client. The message is sent with an HTTP POST request and will have a JSON body containing the attributes of the contact to be created. On the queue, we can see the message count increasing. By picking the queue contents, we can see a preview of the new incoming message with the attributes specified by the sender. The Azure function logs will show that the function was triggered successfully. It has correctly recognized and logged the message details. It also called successfully the custom API on Dataverse. In our model-driven application, the new record has been correctly created and can be accessed from within the standard views. We advise you to review these additional resources to learn more about some of the best practices we applied on the previous demo. You will find recommendations about scaling the solution, security considerations, and general best practices. One alternative to the solution we just described will be to use a Power Automate flow instead of an Azure function. Power Automate has a Service Bus connector that will expose a trigger to start the flow when a new message is received in a queue. By using the Dataverse connector, it's then possible to define an action to create a new row in the contact table. With this alternative, we would achieve a very similar result, but using a low-code, no-code approach. Of course, we will be limited to the actions available in the connectors, while the Azure Function and Custom API approach allowed us the flexibility to implement a custom business logic with our own code. Another alternative would be to rely on the HTTP trigger of the Azure Functions and expose the function itself as an API that can be invoked directly from an external application. In this case, we would lose the decoupling that comes from using the Service Bus queue, as the operation is executed on demand and we'll need to return a feedback to the caller application. API management can be used in this case to implement further security layer and simplify the steps of exposing the API externally. Please see the linked documentation to learn more on using Azure API management with Azure Functions. Let's see another example. For this scenario, we simulated the need of importing a set of data from an external source. For example, we could have an Excel file that has been generated from another system containing a list of tasks which has to be imported into Dataverse. To implement this scenario, we are importing the input file into a staging table in an SQL Server database. Then we invoke a logic app to process all rows in the table and import them into Dataverse. Azure Data Factory will be responsible to orchestrate all these steps as part of a single pipeline. A Data Factory pipeline is a logical grouping of activities that together perform a task. The pipeline allows you to manage the activities as a set instead of managing each one individually. You can therefore deploy and schedule the pipeline as a whole item instead of deploying and executing the activities independently. To start, we create an Excel file filled with a number of rows with placeholder data to simulate the exported file from an external system. The file will contain a list of tasks with title, description, a category tag, the expected duration, and due date. The file is uploaded in a blob container on Azure Storage account, which will be the source of our pipeline. We create an SQL database resource and edit the data model to include a staging table for our data. We include all the columns that are needed to map the file input, plus a status column, import status, that we will use to track the progress of the import process. We create a new logic app resource. The flow will have an HTTP trigger so it can be invoked by the Data Factory pipeline. The flow will get our rows from the SQL Server table, and for each of them we'll use the Dataverse connector to add a new row to the task table. By using the run after settings, we can specify a different action to be performed when the previous step fails. In our example, we have two different steps to set a different value on import status column of the database basing on the failed or success status of the other row action on Dataverse. Our Data Factory pipeline will have two activities. The first one, copy data activity to access blob storage and import data from Excel file into the staging database. Second one, web activity, to invoke the logic app and process the staging table into Dataverse. In a real-world scenario, we will want to automate also the initial file ingestion step as part of the pipeline, for example, interacting with an FTP server. Let's see this in action. Launching the pipeline execution will queue all activities that are defined in the pipeline. The activities are executed sequentially, and we can monitor the status of each step. Rows are imported into the staging table on SQL Server as a result of the successful pipeline execution. The logic app was invoked and all steps have been performed successfully. Records are finally created in Dataverse and visible from the model-driven application. As we mentioned earlier, before deciding to import lots of data into Dataverse, you should consider the option to expose external data in your application in real time. This can be used to avoid importing a physical copy of the data into Dataverse. Custom controls, custom pages, and reports can be used to embed views on external data directly into the UI of your application. This will give the benefit of accessing data on demand only when needed, and avoid moving big amounts of data regularly. It is also easy to apply dynamic filters and fetch external data that is related to a specific context in the user's UI. For example, what is currently displayed on the page. Now, over to Corina for the second part of our presentation.
Thank you, Michele, and hello everyone. Next, we will focus on outbound integration. A Dataverse outbound data integration will take data from Dataverse and make it available to other systems. For your scenarios where an event in Dataverse needs to trigger an integration with an external system, you can consider the next endpoints and common tools. First, plugins can call external web services, and they can also post runtime contexts to Azure services such as Service Bus or Event Hub. Webhooks as well can post the runtime context to external web services, and our most recent feature, Dataverse Business Events, can be used for asynchronous process integration. Then for also automation, scheduling, and event-based integration, tools such as Power Automate and Logic Apps can be used and are triggered by create, update, delete operations via the Dataverse connector. With Power Automate and Logic Apps, you can easily integrate with the connectors ecosystem with more than 1,000 pre-built connectors and have the option to create custom connectors to break down data barriers. For continuous export of data and metadata from Dataverse, we will also discuss the Azure Synapse link for Dataverse service. The main use case for this service is to run analytics, business intelligence, and machine learning scenarios on your data. We have seen customers successfully using the exported data from the Azure Data Lake storage for mainly batch data integration scenarios when the Synapse link SLAs or latency were sufficient. It's good to mention here that the Azure Synapse link service uses the change tracking feature of Dataverse. Change tracking provides a way for you to keep the data synchronized in an efficient manner by detecting what data has changed since the data last synchronized. When you're retrieving data with change tracking, a set of delta changes will be returned by Dataverse. Let's begin our discussion with Dataverse plugins. Dataverse provides an event model for integrating with other systems. It supports triggering custom code and external actions when events are detected in the platform. This event model is known as the event framework. The event framework provides you with the capability to register custom code to be run in response to specific events. Typically, you would use the event framework to trigger custom plugin code to augment or customize Dataverse platform behavior with server-side logic, but you can also use it for integrations with other systems. The event framework can trigger plugins, classic workflows and custom workflow activities, Power Automate cloud flows, messages to Azure Service Bus and Azure Event Hub, and webhooks. We will discuss each of these endpoints next. First, plugins and custom workflow activities registered in sandbox mode can access the network through the HTTP and HTTPS protocols. This capability provides support for accessing social sites, news feeds, services, or web apps. When calling external services from your plugins, please consider the next. IP addresses cannot be used, so you must use a named web address that requires DNS name resolution. There is no provision for prompting the logged on user for credentials, and you must allow connections from Power Platform and Dynamics 365 services IP address values specified under the Azure Cloud Service tag. You can develop plugins in your favorite editor as a compiled class within an assembly built to target .NET Framework 4.6.2. You can access the external web services via plugin code, either using the system.net.webClient class or the latest system.net.http.http client class. Citizen developers can also author low-code plugins today using the common PowerFX library. With low-code plugins, you can run logic on events and also run these plugins on demand. We introduced the ability to call connectors from a low-code plugin, and in this launch, you can invoke stored procedures using a SQL connector. In the future, we want to support even more connectors. These low-code plugins are currently in preview and not yet ready for production usage, but they are very powerful, have great potential, so we encourage you to test and provide your feedback. For service protection limits, these are not applied to plugins and custom workflow activities. However, if your application performs operations that trigger custom logic, the additional computation time that these operations contribute towards will be added to the initial request that triggered them. This computation time is part of the Service Protection API limits. For example, if you batch import records that trigger plugins, the computation time due to the plugin's execution is considered towards the Service Protection limit execution time. For latency, when using plugins for data integration scenarios, it is recommended to use post-operation stage with asynchronous mode. If you opt for synchronous plugins, consider the tight coupling, potential performance issues, and the 2-minute execution limit. Our general recommendation is to design your plugin so that it executes in no more than 2 seconds. If your plugin requires more time to execute, consider registering it for asynchronous rather than synchronous execution. For security, if you need to store sensitive data, maybe even credentials, use the plugin Secure Configuration Data, which is actually stored in a separate Dataverse table that only system administrators have privileges to read, or maybe even a custom table where similarly you would have configured that only administrators have access. It's good to also mention here the Dataverse environment variables of type secret, which are actually references to Azure Key Vaults. And the associated custom API, retrieve environment variable secret value, which used to work with plugins, is designed to work today only with Power Automate. Of course, for retrieving Azure Key Vault secrets in Power Automate flow, you can also use the Azure Key Vault connector. And some recommendations. A well-written plugin is powerful, but a poorly written one can cause significant impact on the performance of the data processing pipeline. The great power of plugins needs to be applied with restraint and consideration for the impact it has on the system as a whole. And there are alternatives. Power Automate, webhooks, or integration with Azure services, which we will explore more next. By using the event framework, we mentioned that Dataverse supports native outbound integration to Azure services. Let's briefly cover the natively supported Azure services first, starting with Azure Relay. This used to be part of Service Bus, but now it is its own service that enables bidirectional point-to-point network connection bridging. Azure Relay follows a request-response pattern so that the calling system can receive a response, such as a piece of data or a success message from the other system. It can run both synchronously and asynchronously. Azure Relay supports 3 contracts: one-way, two-way, and REST. With a one-way contract, it will require an active listener to consume the message you post to Service Bus. If no active listener is available, the post fails. If the post fails, Dataverse retries posting the message in exponentially larger and larger time spans until the asynchronous system job is eventually cancelled. The two-way contract is similar to one-way contracts, except they also let you return a string value from the listener. If you've registered a custom Azure Aware plugin to post your message, you can then consume this return data within your plugin. A common application of this scenario might be if you want to retrieve the ID of a row created in an external system as part of your listener's process to maintain it in your Dataverse environment. And finally, the REST contracts, they are similar to two-way contracts, except that you publish it to a REST endpoint. Then Azure Event Hub. This is a big data streaming platform and event ingestion service with focus on data point event scenarios. Think trends and statistics over time. It can receive and process millions of events each second. Then Azure Service Bus. This is a jack-of-all-trades service for messaging tasks of critical business value. It allows for the creation of routes for messages that need to travel between applications and application modules. A particular strength of Service Bus is also its function as a bridge between elements of hybrid cloud solutions and systems that include branch office or worksite systems. An integration with Azure Service Bus is useful when the likelihood exists that the other system is not available or it is limited in its ability to process high volumes of messages, because those messages can be queued, allowing the receiving system to process the messages as fast as it can. Once the plugin execution context has been posted to Azure Service Bus, subscribers or listeners can process that message. The listener process can be, for example, an app in Microsoft Azure Logic Apps that is triggered automatically when a new message is posted, a function in Microsoft Azure Functions that is triggered automatically also when the message is posted, or even a C# program that runs on premises that can poll the Service Bus for new messages. Service Bus messages are received at an endpoint, also using queues or topics. A queue endpoint will offer message delivery to one or more competing consumers. Using queues to intermediate between message producers and consumers provides an inherent loose coupling between components. Because the producers and the consumers are not aware of each other, a consumer can be upgraded without having any effect on the producer. An active queue listener is not required to send an event to a queue. Topic listeners are like queue listeners with the same advantages, except that one or more listeners can subscribe to receive messages for a given topic. Topics are useful if you require multiple consumers for a given message. Here are some considerations when Dataverse is an event producer sending messages to Azure Service Bus queues for topics. In terms of setup, you can create the plugins and steps that post the runtime context to Service Bus using these two methods. Without code, by creating a step for the event in Dataverse against the Azure Service Bus endpoint, and the plugin implementation context gets automatically posted to the Service Bus. Or you can use code and create and register a plugin in Dataverse that calls the Azure Service Bus endpoint. The message that is posted to the Service Bus can then be customized in the plugin. For example, you can add values in the context object share variables. For security, the Service Bus also provides data security so that only authorized applications can access the posted data. Authorization of Dataverse to post the data context to the Service Bus and for listener applications to read it is managed by Azure Shared Access Signatures, or SAS. For message format, the context sent to the Service Bus can be formatted in XML or JSON in addition to the default .NET binary format. This allows for cross-platform interoperability when Azure-hosted non.NET clients can read Dataverse data from the Service Bus. For latency, integration with Service Bus is asynchronous. Plugins registered will notify the asynchronous service through a service endpoint notification service request, and that will post the current request data context to the Azure Service Bus. You can monitor these requests from the System Jobs view. For our next demo, we will explore a scenario where we will employ Service Bus queues and Dataverse plugins. Let's explore a scenario where you need to notify an external system when an opportunity is created in Dataverse. There are many opportunities created in Dataverse daily, and let's also assume that there are some batch imports of opportunities happening also. Our external system is limited in how many opportunities it can process at a time. It's hosted on premises, and it also needs to communicate with other internal services. This is a type of scenario where we can implement the integration between Dataverse and the external system using a Service Bus queue as a middleware. We will opt for the low-code approach, where we can pass the execution context containing all opportunity attributes to the Service Bus queue, and from there, the consumer can process the messages at its own pace. The steps to implement this are the next. Similarly to what we saw for inbound, we need to create our Azure objects, configure the producer and the receiver. We will create a Service Bus namespace, then a queue to use for actual message delivery. We will then register the queue as a Dataverse service endpoint and add a step for the execution context to be sent as a message to this queue each time an opportunity is created. Then we will configure our receiver, a console application. And finally, in step 5, test the process by creating opportunities, observe these in the queue, and observe the receiver executing a simple logic of outputting some opportunity attributes values. To begin using Service Bus messaging entities in Azure, you must first create a namespace. You can create a namespace in multiple ways with Azure CLI, PowerShell, ARM template. Here I'm just using the Azure portal and creating my resource of type Service Bus namespace. Very important, when selecting the pricing tier for the namespace, if you want to use topics and subscriptions, choose either standard or premium. Topics and subscriptions are not supported in the basic pricing tier. Next, let's create our queue. On the Service Bus namespace page, select queues in the left navigation menu and the plus queue button. For this demo, I'm leaving the default settings, but like mentioned earlier by Michele, consider if for your queue you need custom values for configuration such as time to live, duplicate detection, maximum number of delivery attempts, log duration, and more. Next, for authorization, I am adding a shared access signature policy. These are claims-based authorization mechanisms using simple tokens. At a minimum, the send permission is required to be added on the policy. Copy the URL from the newly created shared access policy, as we will use it for the next step. Now we can run the plugin registration tool, log into our target Dataverse organization, select register new service endpoint, and paste the connection string of our Service Bus messaging entity. We will fill out the service endpoint registration form by entering the designation type, in our case it's queue. Then message format I will change to JSON, and optionally if you want to send the user information. After a few seconds or so, you will see the new service endpoint created. Next, I'll be adding a message processing step for when I want the runtime context actually to be sent to the service endpoint. In our case, it will be create for opportunity. it will be asynchronous, and I'm unticking deleting the completed system jobs for testing purposes. For production, this should remain checked. And now we have the service endpoint pointing to my service bus queue, and we also have our message trigger. We will now want to create our receiver. For this example, I'm building a console application in C#. Then I added code and the necessary packages to parse the message. The receiver you create must parse the Dataverse runtime context to extract the relevant items of information for your receiver to provide its function. How you choose to parse this data depends on the technology you are using and your preferences. Now let's create some opportunities and observe the queue and the receiver. I'm starting the console app receiver, but it will not start listening yet for the queue. It will wait for my command. Then I'm creating an opportunity in Dataverse, provide some opportunity values, and then save. Once my opportunity is saved, a message should become available in the message queue. The message will consist of the runtime context for the opportunity we just created. And here we can see the message is in the queue. Now I'll actually start my receiver, which will start polling the queue. And once it processes the message from the queue, it should write to the console some opportunity attributes like .name and revenue. And here we go, we can see the opportunity details. Now we'll go back to Dataverse to create another opportunity with the receiver running. Then upon checking the receiver, the second opportunity details should also be written to the console. And then here are the values as expected. Please note that this video was sped up. So we have seen how you can pass Dataverse runtime context to a queue, then the receiver poll the queue and process those messages asynchronously. Dataverse also supports calling of a webhook with the event framework. Webhook is a light HTTP pattern for connecting web APIs and services with a publish-subscribe model. Webhooks enable developers to integrate Dataverse data with their own custom code that is hosted on external services. For volumes, webhooks will scale to the point at which the external service can handle the messages. For latency, you can register message processing steps for webhooks for both synchronous and asynchronous modes. For message formats, it's JSON payload. You can secure your endpoint by using an authentication header or query string parameter keys. This approach is simpler than the SaaS authentication model that is used by Azure Service Bus integration. For setup, a webhook with a message step can be registered without any code. It's also possible to invoke the webhook from plugin or custom workflow activity code. The webhook execution timeout is 60 seconds. Generally, if no response is returned before the timeout period, or if the response status code is not within the 200 range to indicate success, it will fail. For 502, 503, 504 errors, the webhook will make one more attempt. For our next demo, let's explore a scenario where we will combine webhook with an Azure function. The scenario is the next. When a contact customer is created in Dataverse, we need to calculate a financial score risk and save the score with the contact details in a separate database. The calculation involves a complex algorithm with input parameters from Dataverse contact details and data from external systems. To implement this, we will use an Azure function, which will actually perform the calculation. We will send the contact details to the Azure function using the webhook model and trigger it for the contact create event. The steps we will follow are the next. First, we'll have to create our Azure function, write the code to parse the Dataverse execution context, and to execute, of course, our custom logic. Then we will publish the function. In step 2, we will register the Dataverse webhook using the Azure function URL. Then we will register a message processing step for the create contact event. In step 3, we will test the integration, create the contact, and observe how our Azure function gets triggered. Our first step is creating the Azure function. For this, I'm using Azure Development Tools installed in my Visual Studio 2022, and I'm creating a new Azure function project by using the Azure Functions template. Then I'm going to update the function logic to interact with Dataverse data and execute the desired logic. Afterwards, I'll publish the function to the Azure portal and save the function URL for the next step. Now I'll use the plugin registration tool to register the webhook that will call the Azure function we just published. I'll register the webhook using the function URL without the code portion and place the code portion as value for the webhook key. Once the webhook is created, add a message step for when it should be triggered, for example, the contact creation in our scenario. Next, let's test our webhook to Azure function integration. Go to our Dataverse environment and create a contact record. When testing, if you use asynchronous steps and you chose to not delete a log, you will be able to observe the system job with succeeded status for posting the runtime context to the Azure function. And here we can see that the context Joanna Smith was sent to our Azure function. Afterwards, I'm monitoring the Azure function. For this demo, my function is writing to the console the contact details read from the runtime context. So we can see actually here the name of the contact we just created. So with this demo, we showed you how you can use webhooks to send a runtime context from Dataverse to Azure function. The function then parses that context so it then can be able to execute any desired customer logic or further integration. Let's spend some minutes now on Dataverse business events to learn use cases for which this new integration mechanism can be useful. We have seen that Dataverse has a robust event framework to capture system events within Dataverse. You can respond to events within the system using the Dataverse event framework, and this isn't changing. With Dataverse business events, we are providing new ways to expose events and compose your business logic to respond to them asynchronously. Dataverse business events include concepts from Dynamics 365 Finance and Operations business events, together with the Dataverse event framework, to provide a new way to discover events and create automation when these events occur. For an event to be emitted, it needs to be added to a catalog assignment and associated with the catalog. There is also a set of design principles you should have in mind when defining business events. There should be a clear intent for definition, specificity, in that a subscriber doesn't need to filter whether or not they should respond to the event. The event should be lightweight, and also consider that business events are not suitable for transferring data. If your intent is to transfer data to a recipient and in effect realize a data export scenario, this is not a good use case for business events. And here are some examples, there are more, of business event scenarios. First, a Dataverse table event or custom API can trigger a business event. So for example, after cataloging the opportunity table, we expose the grant access event. In the past, you could only use a plugin to capture and respond to this event. Now you can respond to it using Power Automate with when an action is performed trigger. Another example is an external system emitting a Dataverse business event by calling a custom API that has been cataloged as a business event as well. The receiver of the event can again be a Power Automate flow. Imagine a scenario where we want to email a customer after they made a purchase. A POS app can call the Dataverse custom API, which would have as input parameters the customer ID, and a flow will then be able to respond to this custom API event by emailing the customer and thanking them for their purchase. Another example is F&O data event integration with Dataverse business events. Imagine a plugin on a virtual table with data source F&O executed when a record is created in F&O. The F&O events catalog is available for linked Dataverse and F&O environments. Some considerations for when you decide to use business events. As we said, the triggers can be table events or custom APIs, and they need to have a catalog assignment. Events are asynchronous in nature. The intent is that any endpoint can register to the event to react to it when it occurs, but shouldn't expect to block the originating function if there is a failure on the registered step. It's just listening for the event to occur and can react as needed. With business events, we allow citizen developers to consume these, for example, with flows. For pro devs, it can help simplify plugin logic or replace plugin code completely. For example, if you have some cascading plugins that are using shared variables, you can simplify this concept by calling from your plugin code a custom API with input parameters. And that could then, for example, trigger a flow, or you can maybe even completely replace the plugin code with a flow. Security for events originating outside Dataverse, we can call the web endpoint of the custom API to emit that event. Make sure to use an application user with OAuth 2.0 to connect the Dataverse custom API endpoint. And finally, let's cover the outbound batch scenario with Azure Synapse Link for Dataverse. Using the Azure Synapse Link for Dataverse service, you can continuously export data from Dataverse to Azure Synapse Analytics and Azure Data Lake Storage Gen 2. This service is designed for enterprise big data analytics, and it create, update, and delete operations for metadata changes for first-party and custom entities for which change tracking was enabled in Dataverse will be automatically pushed to the Azure Synapse Metastore and, like we said, Azure Data Lake without any additional action. For setup, the service is integrated with the Power Apps Maker portal, so you can easily link a Dataverse environment to Azure Synapse Link Workspace. The association between a Dataverse environment and an Azure Synapse Workspace and Azure Storage account is a profile, and this is a component that is solution aware. For latency, this is near real time with a soft SLA of 15 minutes for platform as a service mode when you bring your own storage account. There are many factors that can impact the SLA: initial data sync volumes, number of Dataverse tables added into the profile, number of profiles, number of columns in a Dataverse table, and of course, network latency. Also have in mind that the service has been built for eventual data consistencies. So there is no guarantee that data edits are replicated in the order of user actions on Dataverse. Security, you can limit access to your storage account to requests originating from specified IP addresses, IP ranges, subnets in an Azure virtual network, or resource instances of some Azure services. And you can use the Dataverse managed identity to allow access to your Azure Data Lake for your service to run. Once the data is exported, you have the next options to consume it. And maybe this is where the outbound integration becomes more interesting. You can query Azure Synapse Link for Dataverse data using serverless SQL. You can transform that data with Apache Spark. You can visualize it with Power BI and then use it for UI integration. You can copy it to dedicated SQL pool, and if you want to run ETL jobs, you can use the Azure Synapse pipelines. And some final thoughts to conclude on the inbound and outbound Dataverse integration patterns. We saw how Microsoft Dataverse has a wealth of pre-built methods for interacting with Azure solutions. Whether you intend to integrate with external systems or distribute workloads away from your Dataverse environment, there is a wealth of utilities to make it a seamless and relatively easy experience. For inbound, we talked considerations when using organization service versus web API, how to implement orchestration with Logic Apps, Power Automate, Azure Data Factory, and for outbound, how to use the Dataverse event framework and seamlessly integrate with Azure Service Bus queues, topics, webhooks with Azure Functions, and business events. Next, we will share some useful resources. Here is a compilation of links if you want to learn more on Dataverse and Azure integration services. We strongly recommend the learning paths and the dedicated tech talks. More will come very soon, and the documents comparing the Azure integration services. Of course, you will also have access to the slides when we publish the Tech Talk recording in around a week's time. We also have prepared for easy accessibility comparisons between similar technologies. We have webhooks versus Azure Service Bus. So when deciding between the webhooks model and the Azure Service Bus integrations, you should keep several factors in mind. Webhook is a good choice if there is a third-party API that you want to use, and authentication through authentication headers and query string parameters keys is preferred and feasible. On the other hand, Service Bus is an excellent choice as it provides high-scale processing and full queuing mechanism if Dataverse is pushing many events. Also, if you want to govern your architecture in a centralized location, and authentication through shared access signature is preferred and feasible. Both webhooks and Azure Service Bus can be invoked from a plugin or custom workflow activity. Then Azure Functions versus plugins. Azure Functions can be used to write custom code that is run in Azure. They can also be called from a Power Automate Logic app and can be used for scheduling tasks as well. And they are a great solution when combined with webhooks. In many scenarios, it can make sense to offload Logic to reduce the load on the Dataverse application host, as you have the availability to run functions in a synchronous and asynchronous capacity, with Dataverse webhooks providing the runtime context to the given request. However, the Azure functions don't explicitly run within the Dataverse event pipeline. So if you need to update data in the most high-performing manner before it posts to Dataverse, we still recommend that you use a plugin to perform this type of operation. Also, any data operations you perform from Azure function will not roll back, while for the plugin, if there's an exception during execution, it will roll back the transaction. And finally, Power Automate versus Logic Apps. We have already said a lot about these two technologies. They differ in many ways. For Power Automate, the Dataverse connector has more capability, is packaged as part of a solution, so you have native ALM support, can perform robotic process automation with desktop flows, can use the approvals connector, and has a send notification connector as well. And for the cost, there's a limit on the number of flows you can run each month, and it can be included with the Power Apps licenses. With Logic Apps, on the other hand, we can perform enterprise integration, has a higher performance, can be more easily monitored and integrated with Azure services, has better error handling, and cannot be packaged in solutions. For cost, there's a consumption-based or fixed pricing model through the Azure subscription. Thank you very much for listening. I hope you found these comparison slides also useful. We have a couple of minutes now to address some questions live. Do we have any questions from the chat?
Yes, Corina, thank you. We probably have time for one question. I want to remind everybody that the question we don't answer directly, we try to put in the presentation that we share along with the recording. So I have one question, which is, can you recommend when to use one of these tools, as they kind of have similar capabilities? The tools are Event Grid, Event Hub, and Service Bus.
Okay, I can take this one. So there's a distinction here that we need to be aware of when working with events versus messages, right? Messages, Azure Service Bus and Event Hub are two tools that are suitable for message integrations, while Event Grid is more for event integration. You typically try to combine these services like Event Grid with Service Bus for a reactive programming. So for example, if you don't want to have resources idle, continually polling your queue, assuming that there are not many messages coming into your queue, you can use a model with Event Grid being in the middle to receive that message and then alert your listeners, and then from there they can process the messages from the queue. So they do very different things, but to conclude, Event Grid is for event messaging and Service Bus and Event Queues are for message integration.
All right. Thank you, Corina. And we reached the top of the hour. Thanks to our presenters and to you, our audience, for attending our Tech Talk today. We hope you have a great rest of the day ahead.
Thank you, everybody, for joining.
Thank you for joining.